Planets containing liquid water may be endemic in our own galaxy, vastly increasing the chances of another Earth capable of supporting lifeforms. That's the remarkable conclusion of a study by astronomers that suggests that water may be present during the formation of all planets. Published in the journal Science Advances, a study by researchers from Center for Star and Planet Formation at the Globe Institute at the University of Copenhagen, Denmark, calculated that water was intrinsic in the formation of Earth, Venus and Mars, three of the rocky planets in our solar system. It's often assumed that water got to Earth via impacts by icy asteroids and comets. All our data suggest that water was part of Earth's building blocks right from the beginning, and because the water molecule is frequently occurring, there is a reasonable probability that it applies to all planets in the Milky Way, said Professor Anders Johansen, who led the study. The decisive point for whether liquid water is present is the distance of the planet from its star, he said. The study suggests that all the planets in our solar system formed from ice and carbon dust particles that orbit all young stars in the Milky Way. Since water molecules are found everywhere in our galaxy, a consequence of this so-called pebble accretion theory is that planets with the same amount of water and carbon as Earth may be common around other stars in our galaxy. Just as important an ingredient for any potential planet to be Earth-like is temperature. Only a planet situated between the super-close fire line and the distant ice line in a star system could maintain liquid water on its surface. That's what Earth 2.0 hunters call a star's habitable zone. The model also suggests that other planets with Earth-like temperatures may have not only the same amount of water and oceans as the Earth, but also the same amount of continents as Earth. That's important because a 100% ocean world is less likely to produce intelligent life. A planet covered by water would, of course, be good for maritime beings, but would offer less than ideal conditions for the formation of civilizations that can observe the universe, said Johansen. It's hoped that the next generation of space telescopes, such as the James Webb Space Telescope, will be able to more closely observe exoplanets. Webb will be able to detect the presence of water vapor in an exoplanet's atmosphere. It can tell us something about the number of oceans on that planet, said Johansen. Future observations will test this model, but the theory that all planets get the same amount of water is an intriguing one for anyone interested in the search for life beyond Earth. Wishing you clear skies and wide eyes.